Okay, let's talk about Newton's first law of motion. I can start from a linear air track. Suppose that we have an air track here, but there is an object over that, and the object is at rest. The object has a hat shape, and it's fit to the air track, but at rest. There is no net force acting on the object. You know that the gravity will pull the object downward, and also there is a normal force acting on the object because it's at rest on the air track. So normal force will cancel the W, and the net force, vertical net force, is zero. And to the horizontal direction, I don't see any external force, so I believe that the object will remain at rest. So if the object is not acted by a net force, the object will remain at rest. But if it is moving, the situation is a little bit different. I will tell you why. Let's activate the air track. Here we supply a high pressure air from the bottom of that air track, and the high pressure air is coming out of those tiny holes over, and then this hat shaped object will suspend, and it will have a very small negligible friction. If I push the object with a very small force, this object will move with almost constant speed to the end of the track. And at the end of the track, let's say there is a very high friction, and then the object again stops. During the horizontal motion of the object, you see that it does not need the support of F. At the beginning, yes, I should push the object, activate the motion by a force. But when I accelerate the object and release that, it does not need any more support. It will continue almost forever. If the friction is really negligible, the object will go for a very long distance. So, if the object is not acted by a force and it's moving, it will continue moving. But this type of motion is not an accelerated motion. It's going to be a uniform straight line motion. What do I mean by uniform straight line? The velocity of the object will be constant. Same direction always and same magnitude. Okay. An object is under balanced forces. Let's have a question. Is it necessarily stationary? When we say balanced forces, means that there is no net force. So F net resultant force acting on the object is zero. Can I say necessarily the object is stationary? I think no. You remember from the air track, when the object was at rest, it remained at rest. And when it was moving with no any more support, it could move on a very straight line, constant motion to the end. Why should we necessarily think about a stationary case? No, not necessarily. It can be at rest, but it also can move, but it's not an accelerated motion. If it moves, it's just a uniform, constant velocity motion. So we can say no, not necessarily. It may move with a straight line uniform motion, but of course there is a probability for the object to remain at rest. Newton's first law of motion tells us an object continues to remain stationary or move at a constant velocity unless an external force acts on it. Back to very ancient time, Aristotle had a different view. He said a force had to keep pushing constantly at a moving object for the speed to remain the same. He believed that even if the velocity is constant, you have to keep the supporting force. This mistake most probably roots in the friction. In your everyday experience, let's say I put a box on a horizontal surface, and when I push the object with the force of F, immediately a friction is opposing that motion. So you have to keep that supporting force to the end of the motion to keep the velocity constant. This is why Aristotle expressed his idea like that. But let's remove the friction. What if we don't have any friction? Necessarily we do not need any force. And so the object which is moving can continue its straight line uniform motion without any acceleration, without any necessary supporting force. So from now on, we do not believe such a wrong idea. I will continue with the concept of inertia. Tendency to keep the previous state for an object is called inertia. Actually, the property of mass is called the inertia. Every massive object, everything which has mass, tends to keep its initial state. Initial state means if it's at rest, it remains at rest. If it's moving, it will continue straight line uniform motion. Let's focus on an object at rest. This cup is on a paper over the table and I quickly pull that paper. If I quickly do that experiment, almost the cup remains at rest at that initial location. It won't move. It is called static inertia. Static inertia means the tendency of the object to remain at rest. The other could be when you are driving and you have an accident. Before a very sudden stop, your body got used to the motion. So it's in motion, it wants to keep and continue moving. And because of that, if you don't fasten your seatbelt, you will get out of the car. So this is why they say you should fasten your seatbelt. It is called kinetic inertia. Kinetic inertia is the tendency of the object to keep moving. So we have two types of inertia, static inertia and kinetic inertia. So inertia is the property of mass. Every massive object will have inertia, means that it will comply the Newton's first law of motion. Okay, thank you for your attention. The next video will be about Newton's second law of motion. See you very soon.